Milestone achieved.
I'm Edward O. Martian, and you're listening to Mars Vision Radio, the bringer of the Mars Vision Song Contest. Don't miss out. Keep listening.
Resources are low.
Earth-Mars synchronization happens roughly every 2 years. So every 2 years there's an opportunity to fly to Mars. So then in 2024, we want to try to fly 4 ships. 2 of which would be crewed, and 2 of which, two cargo and two crew. The goal of these initial missions is to find the best source of water. That's for the first mission. And then the second mission, the goal is to build the propellant plant. So we should, particularly with 6 ships, there have plenty of landed mass to construct the propellant depot, which will consist of a large array of solar panels, very large array, and then everything necessary to mine and refine water, and then draw the CO2 out of the atmosphere.
Sector scan.
And then create and store deep cryo CH4 and O2. Then build up the base, starting obviously with one ship, then multiple ships, then start building out the city, then making the city bigger, even bigger. You send the spaceship up to orbit, you retank it or refill it until it has full tanks, it travels to Mars, lands on Mars. For Mars, you will need local propellant production. But Mars has a CO2 atmosphere and plenty of water ice. That gives you CO2 and H2O. So you can make, therefore, CH4 and O2 using the Sabatier process. Becoming a multi-planet species. Beats the hell out of being a single planet species.
Elon Musk has a giant new addition to his plans for colonizing Mars, the Starship Rocket. For years, this rocket was merely a concept on paper, but not anymore. On Saturday, September 28th, Musk stood in front of a fully assembled prototype of the rocket as he unveiled SpaceX's future plans.
Which future do you want? Do you want the future where we become a spacefaring civilization and are in many worlds and are out there among the stars, or one where we are forever confined to Earth? And I say it is the first.
If all goes according to plan, when Starship is complete, it will tower 387 feet tall, measure 30 feet in diameter, and be capable of transporting people to Mars. For comparison, it will be about 5.5 times taller than SpaceX's first successful rocket, the Falcon 1. Starship is the rocket that Musk has aspired to build ever since he founded SpaceX in 2002. And after years of modeling, multiple changes to the rocket's design, and a substantial investment from Japanese billionaire Yusaku Maezawa, it has come out looking unlike anything SpaceX has ever built before. For example, SpaceX's Falcon 9 rockets are covered by an aluminum lithium alloy. But as you can see, Starship is covered with something different, which Musk called the best design decision of the entire project.
Steel is the best design decision on this whole thing, is a 301 stainless steel. Because at cryogenic temperatures, a 301 stainless actually has about the same effective strength as an advanced composite or aluminum lithium. Unlike most steels, which get brittle at low temperature, 301 stainless gets much stronger.
Full of
And
hope
unlike the 9 engines
determination.
on SpaceX's Falcon
The first
9
founders
rockets,
have set
Starship will
foot
fly
on the
on
red
6
planet.
more powerful Raptor engines.
The ship will have
New
a total of 6
colonists have
engines,
arrived.
3 of the sea level variety of Raptor, and those are actually on the rocket right now. In fact, that's a picture of just inside that skirt. That's what it looks like. And they gimbal, which means that the whole engine moves. So the way a rocket steers is by moving the entire engine. So whereas an aircraft engine is static and you move by moving like the control surfaces like the ailerons and rudder and elevator and flaps, with the rocket, when the engines are powered, you move the entire engine to steer it. The Starship will have 3 sea level engines that move up to about 15 degrees angle, and 3 vacuum engines that are optimized for efficiency that will not move. So they will be just fixed in place.
Musk said that within the next 1 to 2 months, SpaceX will launch this Starship prototype called Mach 1 to 12.5 miles in the air and then land it back home in Boca Chica, Texas. After that,
Our next flight after that might actually just be all the way to orbit with a booster and the ship.
the prototype shown here will probably never reach orbit. That mission will go to an upgraded version of the rocket called Mach 3, which SpaceX could start constructing as soon as next month. And by next year, Musk says SpaceX could be launching people to space on this thing. Whether that's actually the case, we'll just have to wait and see. In the meantime, Musk remains optimistic.
To Mars. Exactly.
In September 2017, SpaceX CEO Elon Musk revealed his latest aspirations for colonizing Mars. His plan is to send the first humans to Mars in 2024 to build the foundations for the first Martian city. But is Mars really the best place for humans to settle? Some scientists think that we should be looking elsewhere.
I'm Amanda Hendricks. I'm a senior scientist with Planetary Science Institute. First of all, I don't want to be too negative about Mars. I like Mars. I do think we should go there, and humans should go there to visit and check it out and do science. I just don't think it's a good place for living for long term. And the main reason is because of the radiation problem. And Mars offers no natural protection against the galactic cosmic rays. It has a thin atmosphere and no magnetosphere. So humans who intend to spend any long period of time on Mars are probably going to have to live underground or in some sort of devices that can shield them from galactic cosmic rays. Titan, on the other hand, has got this natural shielding device, which is its nice thick atmosphere.
Amanda Hendricks believes the planet we should be looking into is Titan, a moon slightly bigger than our own that orbits Saturn.
Because it's such a more appropriate environment for humans. Titan is really unique
Resources
because
are low.
it's a moon and it has a solid surface. It's mostly an icy moon, but it has this thick atmosphere. And it's unique because there's no other moon in the solar system that has such an atmosphere. The atmosphere is mostly nitrogen. It's about 1 to 2% methane. So one thing to point out is there's no oxygen in the atmosphere like we have here on Earth. And so humans living on Titan would need to make oxygen to breathe. Shouldn't be a big problem because there's plenty of H2O frozen on the surface and in the subsurface. So humans could derive oxygen to breathe without a big problem. Perhaps a good option might be for them to try out a very temporary short-term colony of humans on Mars and use that as a stepping stone to
Our
Titan.
colonists are
Use it kind of as a practice run. I think that would be a great idea. But somebody like Elon Musk has got
There
the
are
resources and the
Earth-sick
smarts to be able
colonists.
to work on Titan and to make a colony there happen and to make the propulsion system happen. And so I think he should be thinking about Titan more than Mars.
Sector scanned.
With towering volcanoes, swirling dust storms, and plumes of sublimating dry ice at its poles, the surreal landscape of Mars has captured earthly imagination for centuries. But what would it take to make it habitable? As in, a place where we could breathe, walk around without our blood boiling, or even grow crops and enjoy blue sunsets. There have been some wild proposals about how to make Mars more suitable for humans, from nuking the poles to hijacking a fleet of comets in order to kickstart a new climate. So, how close are we to terraforming Mars? Terraforming is a term that was coined in science fiction, but today, the idea is being thrown around by a handful of actual scientists.
Terraforming, put simply, is changing the atmosphere and climate of a planet so that it can support human life without the need for spacesuits.
To survive on Mars, that is, without extensive equipment and resupply from Earth, we need to be able to do a few simple things. Breathe, stay conscious, and not freeze to death. If we can figure out those 3 hurdles, we'd have the luxury of worrying about longer-term concerns, like how to grow food or shield ourselves from radiation. True, Mars doesn't sound that hospitable, but after multiple missions, we found clues that this wasn't
Research
always the
complete.
case.
We see evidence that there was liquid water running over the surface of Mars. The atmosphere must have been thicker so that greenhouse trapping of heat from the sun would warm the planet and allow liquid water.
Most of Mars' atmosphere escaped to space over the last 4 billion years.
To restore it to a version that's more livable for humans, we'd have to address breathing first. On Earth, we have a delicious atmosphere made of around 21% oxygen, 78% nitrogen, and a little bit of everything else.
It wouldn't need to be exactly that mixed, but we would need a very similar amount of oxygen. But there certainly is enough water locked up in ice on Mars to get some O2 for you. And unfortunately, there probably isn't enough nitrogen that we could easily get to build up an Earth-like, mostly nitrogen atmosphere. If you're willing to wear, like a gas mask, then the gases could be pretty much anything which isn't corrosive or acidic. You have to carry oxygen on your back. That could be an intermediate step.
Okay, fine. I'll agree to wear a DJ Marshmallow mask for a little while if I could skip the spacesuit. So that brings us to our other goals, staying awake and warm. And it turns out these two actually go hand in hand. If you stepped outside on Mars today, you'd pass out instantly and die shortly after, as the low pressure literally pulled the oxygen out of your blood. Temperatures on Mars sit, on average, at a chilly minus 63 degrees Celsius. But if we could thicken the atmosphere by adding some mass to it, we might be able to kickstart a greenhouse effect that would stabilize the temperature and stave off some of that deadly radiation as well. That's the essence of terraforming.
So the question becomes, is there enough CO2 anywhere on Mars that we could mobilize it and put it back into the atmosphere?
In terms of the very first sort of easy baby steps of terraforming Mars would be the release of the kind of easily accessible CO2. Now, this is the south pole of Mars here. It's kind of hard to see there, but it's some water ice, but mostly the CO2 ice down here. If you started making the planet warmer, you would sublimate more of it, or you could just nuke it.
The fast way is drop thermonuclear weapons over the poles.
That would only double the atmospheric pressure on Mars. So we would go from 6% of the Earth's atmosphere to 12%. And that's so not enough to heat up the planet.
Other sources of that desirable atmosphere for terraforming could be hiding in Martian minerals and dust, but they're tricky to unlock.
Carbon-bearing minerals have to be heated up to several hundred degrees, so you'd have to strip mine the planet globally in order to mobilize that CO2.
Mars has 140 trillion square meters. So that's about 1 million billion tons of gas that we would need dug up out of the ground and then vaporized or somehow released from those minerals. And the energy required to do that is staggering. You'd need the equivalent of running 10,000 gigawatt nuclear power plants constantly for 10 to 40,000 years.
Now, we might be able to use something more efficient, a super greenhouse gas like hydrochlorofluorocarbons, for example. But we need to build hundreds of factories on the planet's surface to pump out enough of it to affect the climate. Then, of course, we'd have to add back in our custom cocktail of gases, to allow us to take off our gas masks and tanks, let alone grow any crops. So let's investigate our next option, stealing the building blocks of an atmosphere from comets.
There is a large source of nitrogen, oxygen, hydrogen, etc. in the form of comets. If you could redirect something like, depending on how big they are, 10,000 to 1 million comets, and you were able to crash them into Mars on purpose, that would be possible given the sort of distribution of comets that we have now.
If you've got 1 million kilometer-sized objects hitting Mars, that would be pretty damaging. It would probably devastate the entire surface.
But really what you would need would be an army of self-replicating robots that could essentially attach what people call mass drivers, which would be, let's say, a nuclear power plant on a comet, which could be fed by the water of that comet, and then would use that same water as propellant to act like a rocket, and over the course of years, redirect those comets to eventually impact Mars.
Sounds like some pretty heavy lifting. But with a new global enthusiasm for space exploration at lower costs, we might see some of the technical advances required to inch us closer to this vision, like autonomous navigation and in-space assembly of spacecraft, sooner than we think. But even if we can build and master all of this technology, should we charge forth in aggressively tailoring the solar system to our species' comfort zone? And how much should we promote the idea of having a spare planet in our backyard?
The danger in doing that is that we then think that we can muck up the Earth and we have a place to go. Given the difficulty of terraforming Mars, it's always going to be easier to keep the Earth's environment habitable, to repair any damage we do, than to fix Mars.
So, while we work on making sure our own planet's climate is livable, all we need to do to fix Mars up is figure out how to create legions of artificially intelligent robots, which can create copies of themselves out of Martian dust to help set up operations and vaporize 1 million billion tons of rock. Or we could build hydrochlorofluorocarbon factories, or we could capture, redirect, and crash land 1 million comets onto the planet's surface without completely obliterating it. So how close are we to terraforming Mars?
Today, the emphasis is on getting a first human mission, and even that is really hard and really expensive.
Then we need to establish a scientific outpost to show that there's some level of sustainability on Mars as it is today, because we need to learn how to live on Mars as it is today before we can even begin to think about terraforming. The difficult part for me is seeing how from the scientific outpost, the sort of 10 or 20 or 30 people, up to the kind of 10,000 people that it would take in order to really start the terraforming project.
And that really requires a city on Mars. Is that 100 years into the future? 500 years? To my mind, anything beyond 30 years into the future is science fiction.
I think the people who ultimately terraform Mars are going to be Martians. They will have been adapted by generations upon generations of living in lower gravity. They'll be a lot taller than us. They might have different blood chemistry. They will ultimately start to diverge somewhat as a species from us, and evolution will slowly take over, and they're still going to be humans. They're still going to look like us, but they'll be different enough from us that they'll be easily identifiable as like, oh, that's an Earther, that's a Martian.
Mars might be a long shot, but you can orbit Planet Seeker by hitting the subscribe button right now. Let us know what you want to learn about next in the comments below, and thanks for watching. See you next time.
People on Earth like to talk a lot about colonizing Mars. But what if it had already happened, and the first humans had already settled down on the red planet? What would life on Mars look like? Would we be able to live on the surface or have to hide underground from all the solar radiation that Mars gets exposed to? Would we be able to terraform it? This is What If, and here's what would happen if we lived on Mars. Ever felt like getting off this planet? Well, consider Mars, fourth rock from the sun. It can be as close as 56 million kilometers away. It can also be as far as 401 million kilometers away. Even if you jumped into the fastest craft ever launched from Earth, getting there would take anywhere from 40 days to 9.5 months, depending on the position of the planets. And after all that time spent in space, you'd finally see dry and lifeless Mars on the horizon. Would you be able to survive there? What would you need to survive on Mars anyway? First off, you'd have to figure out how to produce oxygen to breathe. The Martian atmosphere is very thin, and it's 95% carbon dioxide. You wouldn't be able to just bring the oxygen you need to survive, but you could extract it from the carbon dioxide with machines like NASA's MOXIE. Not only would that provide you and other Martian settlers with breathable air, but also supply you with liquid oxygen propellant. That's the stuff you'd need to lift a rocket off Mars in case you decide to return to Earth. There's no fertile soil on Mars to grow food in. Instead, you'd use hydroponics, cultivating your crops in a mineral and nutrient solution. No soil required. Of course, without running water on the surface, your colony would only be able to grow 20% of the food you'd need. The rest of it you'd have shipped in from Earth. But don't expect fresh meat humans to bear. Forget about suntanning. The sun would appear just half as big as it does from Earth. And if you want to go outside and return alive, you'd need a spacesuit to make up for the near-absent atmospheric pressure and to block radiation. Your suit would also keep you warm, which is important because temperatures on Mars are very low. The coldest winter on Earth is paradise compared to the average Martian winter. Temperatures would be as low as 55 degrees below zero. Even colder at the poles, where the temperatures can drop to a freezing minus 153 degrees. A day on Mars is just 40 minutes longer than a day on Earth. A year on Mars would be almost twice as long, though. If you lived in the northern hemisphere, you'd enjoy 7 months of spring and 6 months of summer. Then there would be a 5-month-long autumn and another 4 months of winter. And not only are the temperatures there low, they can also change dramatically within a week. These variations often result in powerful dust storms. They wouldn't harm you, but they'd clog all your electronics. Remember too that the gravity on Mars is about 1/3 of Earth's. You'd need to learn how to walk again. Still want to move to the Red Planet? Well, your best bet is to wait until the first human colonies head there to terraform the planet, to make it just like the one they came from. They'd import ammonia ice from the atmospheres of other planets to heat Mars up a little. The heat would convert the dry ice at the Martian North Pole into gas and give the planet an atmosphere. Still unbreathable for us, but at least it would be enough to create atmospheric pressure so that you could finally take off your spacesuit. Then, they'd extract water from the vast reserves of water ice locked beneath Mars's surface. Water vapor would make the atmosphere thicker and thicker. Eventually, you'd see it raining and snowing on Mars. And after maybe 1,000 years, there'd be enough oxygen for humans to breathe. The planet re-engineering would be complete. Is living on Mars something you'd like to try? Or would you rather preserve what we have here on Earth?
Elon Musk's mission to Mars might sound like a fictional story, but the billionaire's vision is quickly heading towards reality. If he and his brainchild SpaceX can take the human race from Earth dwellers to a multi-planetarium race, it will be the most ambitious and expensive project in history, costing up to $10 trillion. In today's video, we're looking at Elon Musk's timeline to colonizing Mars and ultimately the cost of this intergalactic endeavor. The initial idea of Musk's to get man to Mars started way back in 2002, when he was in the midst of selling PayPal and pondering on his sofa, what's next? How building rocket ships and exploring the universe became the obvious progression is a mystery. But either way, the seed for SpaceX was well and truly planted. After seeing that there was nobody with a space program for Mars exploration in place, instead of being discouraged, Musk started working frantically on making the journey both financially and literally possible. The initial idea was to send a small greenhouse to Mars, packed with dehydrated nutrient gel that could be rehydrated to grow small houseplants on arrival. Sounds a little pointless, I know, but what you would get is a glimpse at the very first life on Mars, to our knowledge, invaluable data about what it takes to keep something simple like plants alive on Mars, and a set of inspiring photographs that might just get the planet excited about space travel becoming legitimate. With no expectations of turning a profit, Musk said that if he could afford it, it would be a worthwhile expense. However, he quickly realized that he couldn't. The cheapest US-made rockets were $65 million a pop, and he would need 2 of them. Russian-made ones would have been much cheaper at $20 million each, but with 1960s technology and questionable reliability, the Soviet offerings were also out. It quickly became apparent that people weren't going to Mars not because they didn't want to, but because it was just too expensive. Nobody is standing in line to send $130 million into space with no scope for a return. So the mission to Mars became more about improving rocket technology, making it more efficient and cost-effective than simply getting to the destination. Okay, the end goal is to get people to the destination and hopefully be able to get back too. But progression in rocket technology is now at the core of what SpaceX does and is the backbone to what they can potentially achieve. Assuming all goes to plan, Musk believes that the first SpaceX rocket could be heading for Mars as soon as 2022, and a permanent, self-sustaining city could take shape as early as 2050. Here's how it's going down and what the future plans are for this once unimaginable quest. Everything that SpaceX has done to date has very much been paving the road to Mars. The countless satellite launches, hop tests, and rocket technology developments have instilled confidence in Musk's ability to deliver his vision. 2020 will be the year of testing and funding. With 3 launches completed already this year and more than 36 in the pipeline, I think saying that SpaceX are perfecting their craft would be a real understatement. 24 of the 35 launches intend to carry 60 Starlink internet satellites, which will form SpaceX's super-fast broadband service. The internet venture is said to bring in around $22 billion in profits yearly by 2025. Who needs investors when you can sell the world's most sought-after commodity, Wi-Fi? 2020 will also see SpaceX sending out its first manned rocket, which could launch as early as May. 2021 will see SpaceX flagship rocket, the Starship, embarking on its very first commercial flight. The Starship will be the first ever fully reusable rocket and will be able to bring things into space, be it people, satellites, or Mars rovers, and bring them back too. The Starship will also lay the foundation for Musk's plans to replace traditional airplane travel with rocket travel. He says that with the use of reusable launchers and passenger rockets, you could fly anywhere in the world in around 30 minutes for the price of a regular economy plane ticket. 2022 will be the absolute earliest year that SpaceX reaches Mars. Every 2 years, Earth and Mars align at their closest point, so it's naturally the best time for a launch. Musk has suggested that in 2022, he would like to send at least 2 unmanned ships to the Red Planet, carrying up to 100 tons of power, mining, and life support infrastructure for future flights. The likelihood of these flights going ahead are slim, but with Musk, you really do never know. 2023 is when SpaceX has sketched in its most solid date in their diary. This is when they plan on sending Japanese billionaire Yusaku Maezawa along with 6 to 8 other accompanying artists on a trip around the moon and back. This will be SpaceX's first commercial passenger flight, and its success would fare well with cautious onlookers who question the place of rocket technology in passenger travel. If the 2022 plans for Mars do not go ahead, which is probable, 2024 will be the next time the 2 planets align, so will be the ideal moment for a second attempt at sending the first Mars-bound shuttles of cargo. If SpaceX manages to send the 2 ships successfully to Mars, Musk says that the next steps will all point towards
Sector
a fully
scan.
manned mission.
Anomaly
The interplanetary
found. No
pioneers would be
active
tasked with
research.
setting up
Research
a propellant
complete.
production plant where they would make rocket fuel by combining Martian ice water and carbon dioxide to create methane and liquid oxygen, aka rocket propellant. Being able to create this fuel on Mars would be vital, as it would be their only guaranteed ticket home. Musk has said that the first visit will be by no means a leisurely one, and any future ventures to Mars rely on its success. 2025 is the earliest year that Musk believes his Mars colony could really start to take shape. The lead Mars development engineer for SpaceX explained that subsequent launches following the very first would build on what's already there. With every new Mars landing, growth and expansion would be the underlying goal. He says that the idea would be rapid expansion. Start with a village, then a town, growing into a city, and then hopefully one day, multiple cities. The city centres would house habitats, greenhouses, and life support infrastructure to serve surrounding suburbs. With 2026 being the 3rd alignment, this year will most likely see more ships being sent to Mars than ever before. What's gone up in the years prior will test the waters, and if it seems legitimately viable, which Musk believes it will be, 2026 will see the Mars city really establish itself. If 2026 sees real infrastructure and permanent habitable places popping up on Mars, having a fully fledged city by 2050 doesn't seem like such an out-there proposition. By the end of this decade, Musk believes strongly that he will have some sort of settlement on the Red Planet, and that in his lifetime there's a 70% chance he'll make a personal visit himself. Whether or not SpaceX will be able to stick to this master plan is one thing, but what about the big elephant standing in the room? Financials. Musk has left the door wide open when answering this question, stating that putting a city on Mars within the next 3 decades could cost anywhere between $100 billion and $10 trillion. The finance calculations are based around the thinking that a city on Mars would require the transport of 1 million tons of cargo, minimum. A low estimate of $100,000 per ton is how we get to the $100 billion number. But this doesn't take into account the cost of everything that goes on behind the scenes. Rocket scientists and astronauts are not known for being very cheap, and SpaceX is going to need quite a few of them. Development of materials, endless amounts of testing, licensing, insurances, all of these things cost money, and money that will indefinitely play a significant part on the suggested bottom line. It's not set in stone that Musk is going to be able to afford the venture, but the potential of $22 billion a year from the internet company sure is going to help, if $100 billion covers the cost, that is. If the cost of building the Mars city raises even close to the upper estimates, we will be venturing into a whole new ballgame. $10 trillion is an almost unimaginable amount of money and would make the venture the most expensive construction project in human history. Being so ludicrously costly begs the question of why does Musk actually want to do this? I'm sure one of the first things that you learn in entrepreneur school is to not throw loads of money at something that's not likely to turn a profit. But maybe there's more to his plans than just money. In a 2018 presser, he said that there's so many things that make people sad or depressed about the future, but I think becoming a spacefaring civilization is one of those things that makes you excited about the future. That is the intent of Starship, to make people excited about the future. The fact that getting the human race to Mars could be the most expensive project in history doesn't seem to bother Musk in the slightest. Maybe he has some hidden tricks up his sleeve that will land him a pretty return, or perhaps he simply believes that you can't put a price tag on leading human exploration. One thing that's for certain is that Elon Musk and the work of SpaceX is making the here and now an incredibly exciting time to be alive. We will all be watching with eager eyes over the next few years as the true potential for Earth 2.0 starts to come to light. The proposed cost of a ticket to Mars is set to be around $250,000, with the idea being that you can sell your home and buy yourself a new life on Mars. If Musk is successful with his timeline, will you be buying a ticket in 2050?
Half a century ago, we took our first step on the surface of the moon. Today, there is renewed passion to explore for our next human endeavor. Mars, the red planet, further than any human has ever been. We face many challenges: remoteness, no livable atmosphere, high radiation, dust storms, and extremely low temperatures. Before any humans set foot on Mars, we must first design a protective shelter. We will protect our astronauts from radiation with a thick 3D printed shell structure using Martian regolith, which works great in compression but does not perform well under tension. To overcome this shortfall, we have chosen to construct the pressure-retaining parts of the habitat from lightweight inflatable pods. They will be made out of high-precision engineered composites that are prefabricated on Earth. Their elliptoid geometry will be able to mitigate the pressure differences whilst optimizing spatial planning. To create the base on Mars, we will use a two-phase approach. In Phase 1, an ecosystem of 3D printing robots will arrive months in advance of any
Anomaly analyzed.
They will construct the protective shield for the base by adopting a modular robotic swarm strategy, a plan that allows for redundancies and enhances the odds for success. Intelligent autonomous robots will have interchangeable roles, from battery storage to scout rovers, logistics to excavational, and even 3D printing units, all integrated with multiple cameras and sensors for navigation. They can reconfigure themselves for a multitude of purposes, ensuring prolonged usage beyond the initial build phases. The smallest configuration is the one-wheeled scout rover that uses ultrasonic scanning to analyze the Martian surface to determine the best regions for obtaining optimum regolith. The digger receives the location coordinates and then excavates the Martian soil. It then delivers the payload to the refining assemblies. Here, large chunks of Martian regolith can be processed down to a finer grain and then delivered to the melter robots in situ. They then use concentrated microwaves to melt the regolith and extrude through the 3D printing nozzle. The shell is autonomously 3D printed, layer by layer, over several months by the robotic system. In the next phase,
building a new
first
home on an
astronauts
alien
arrive with
world.
the habitation units, equipment, and supplies. The robots now take on their second life roles to aid the next phase. They come together to make flexible mobile platforms that can carry the payload from the loading zone to the base. The convoy begins its journey across the Martian surface to the habitat site. The build commences with a connector module placed underneath the protective shield and ready for inflation. The module then unfolds and self-inflates into its final form. The habitation units are then placed into position and sequentially inflated to form the completed pressurized environments. The circular layout of the habitat ensures continuous accessibility of the habitat in the event of a catastrophic failure. Each connector module houses 3 integrated environmental control life support systems, delivering essential services like power, water, data, and oxygen to all the habitation units. A circular conduit delivers these services to multiple endpoints in each pod. The base will be remotely powered by 2 nuclear kilopower reactors in a solar farm, located a safe distance away from the base. In the next stage, the astronauts will construct and install a flat-pack, rail-based racking system capable of connecting to the distribution system, enabling spaces to reconfigure according to their spatial needs. This modular and radical design principle has been adopted for all the habitat pods, ensuring multi-use, reconfigurable environments. A Martian base should not just be a habitat. It is home for the astronauts. Each pod expresses its own identity, quality,
Anomaly
and character.
found.
A highly functional design which places the human experience at the core. Spaces include a state-of-the-art research laboratory, a hydroponic greenhouse, a fully equipped workshop with digital fabrication facilities, the sleeping quarters with gym facilities,
No active
and immersive
research.
virtual reality
Research
platform.
complete.
We believe that the key to success of human habitation on Mars is the health and well-being of its residents. Creating a place where work, life, and living combine holistically to ensure they feel connected to each other, to themselves, and somehow to their distant home.
When it comes to colonizing new worlds, Mars could be humanity's best option. But the journey won't be like it was in the past for pioneers like Magellan, Gagarin, and Neil Armstrong. This new frontier will be the most extreme challenge yet. It's not just learning how to survive on an alien planet with less oxygen, a weaker gravitational pull, and more harmful radiation. It's enduring the changes that these extreme conditions will have on the human body, manipulating it in ways that we can only begin to imagine. Even astronauts know that you don't have to spend much time off Earth to notice changes. The lower gravity can kickstart a whole list of physical alterations. Just ask this guy, former NASA astronaut Scott Kelly. He lived for an entire year on the International Space Station. Without Earth's gravitational pull, the zero gravity weakened his bones and muscles and expanded the space between his vertebrae, making him 2 inches taller. Now, the zero gravity environment in space is more extreme than on Mars. However, these changes could still happen
No
at smaller
active
scales.
research.
And if you compound them over hundreds of years and tens of generations, the results could be similar and even more pronounced. Basically, humans will adapt to Mars's conditions in one of two ways. In the first few centuries, our skeletons and muscles will likely shrink and will become weaker versions of our Earthling counterparts. This would almost certainly lead to shorter lifespans and health complications, including neurological disorders if our skulls shrank with the rest of us. So to survive, we may, over millennia, actually undergo the opposite reaction, evolving stronger, more robust bodies like the Tharks in Edgar Rice Burroughs' sci-fi novel,
Electrostatic
The
dust
Princess
storm
of
approaching.
Mars. Although, us having 6 arms and green skin is less likely. In fact, some scientists think we actually develop orange skin, not green. Turns out, the carotenoids that make carrots, sweet potatoes, and pumpkins look orange offer a certain amount of protection against harmful UV radiation. When we eat these pigments in large amounts, we actually get a boost of protective carotene in our bloodstream and under our skin. So yeah, eating too many carrots can turn you orange, but it may also be a great defense against cancer on Mars. The planet's thin atmosphere lets in massive amounts of UV and other high-energy radiation compared to Earth. For example, the average Earthling receives about 3 millisieverts of radiation per year versus the 30 that they would get on Mars. To compare, here's the minimum radiation dose it takes to drastically
Anomaly
increase
analyzed.
your risk of cancer. Add up the annual radiation levels on Mars over a lifetime, and the average Martian would receive 5,000 times more radiation than someone on Earth. And our big orange bodies may not just look different on the outside. One of the most profound changes we could have coming is the next species of human. Higher levels of radiation on Mars' surface would mutate the DNA in our cells at an accelerated
Our
pace.
colonists are suffocating.
Normally, a species like Homo sapiens could take a few 100,000 years to evolve on Earth. But some scientists say the higher mutation rate could spawn new human species within centuries, 10 times faster than on Earth. So, if the radiation didn't outright kill us, the mutations that survived would be passed down for generations, ultimately diversifying the gene pool and allowing natural selection to do its job. As exciting as it may sound, there is a potential downside to all of this. If, one day in the future, a Martian falls in love with an Earthling, it can only end in tragedy. The immune systems of Martians and Earthlings would be completely different, and a meeting between the two could be just as deadly as when 2 foreign groups have met in the past, like the European settlers who gave smallpox to the Native Americans. Also, depending on how genetically different they are, even if they could meet, they may not be able to have Martian Earthlings of their own, since only closely related species can reproduce.
Research
Moving to Mars may be
complete.
the best chance for
Anomaly
humanity's
analyzed.
survival, but it may not be humans who live there in the end.
Resources are low.
There's a question that's been coming up a lot lately. Should we build a base on the moon? We could totally do it. We have the technology. And a lunar base would mean lots of new science, plus a possible refueling station for missions heading to Mars. It would be a huge, expensive project, but space agencies are starting to come up with more concrete plans. According to a team of space scientists from NASA and the US spaceflight industry, it would take us just 5 years to build a base on the moon if we wanted to. And the ESA is developing a separate set of plans to build a lunar base by the 2030s. First, let's rewind back to August 2014, when about 50 space scientists, both from NASA and from the commercial spaceflight industry, came together for a workshop organized by Steve Jurvetson, a venture capitalist on the board of SpaceX. They spent the meeting discussing how to build a moon base as quickly and inexpensively as possible. And in March of this year, the results of that workshop were published as 9 separate papers in the journal New Space. Their conclusion basically was that with the technology we have today, or that will be available soon, we can establish a permanent base on the moon by 2022. For about $10 billion. So, not exactly cheap, and not easy either. The crew of a lunar colony would need somewhere to live, not to mention enough food, air, and water to survive. That means transporting tons of supplies
Resources
from Earth to the
are
moon,
low.
which would be incredibly expensive. Still, it is getting cheaper to send things to space, and with advances in technology like 3D printing and robotics,
building a habitat on the moon is much more doable than it used to be. The researchers
first
are proposing that we
colonists
set up
are
shop
all
near the moon's
gamblers
north
coming
pole,
to-
where the terrain is relatively easy to navigate and there's a lot of sunlight. See, the moon rotates on an axis that's almost exactly perpendicular
This will go
to its path
down
as
in
it travels
history.
around the sun with Earth. At the moon's poles, though, you'd be able to see the sun near the horizon pretty much all the time, assuming you weren't stuck at the bottom of a crater or something, because unlike other parts of the moon, the poles don't really experience night. So if we want to use solar power for a moon base, it makes sense to put that base at one of the poles. First, we'd send rovers to scout it out, looking for the perfect place to set up a habitat and figuring out what resources we'd have to work with. Then we'd drop off a power source and construction equipment that we can operate from here on Earth. Eventually, we'd send along habitats, probably something inflatable, which the construction equipment would set up. Finally, once everything was in place, we'd send a crew of up to 10 people who'd stay for 3 to 4 months before the next set of astronauts took over. The crew would do experiments, but they'd also help continue developing the base. The cost of all this? $10 billion to build in just 5 years total, and $2 billion a year after that to keep it going. Right now, NASA's budget for deep space crew missions is about $3 to $4 billion per year, which makes this possible, at least in theory. The thing is, we already have plans to send humans to Mars within the next couple of decades, and those plans are going to take most of the budget. So, will we actually see a NASA base on the moon in the next few years? Probably not, unless NASA gets a much bigger budget or changes its goals. But NASA's not the only space agency with an eye on the moon. The ESA is also talking about establishing a permanent lunar base, though their goal is to do it by the 2030s. And their plan is a little bit different from NASA's. In December 2015, the ESA organized a meeting of about 200 scientists to talk about what it'd take to create a permanent human presence on the moon. And they ended up proposing a base that would be kind of like the International Space Station, with different countries and space agencies contributing
No
to the effort.
active
This plan involves
research.
building the base near the
Research
moon's
complete.
south pole,
Anomaly
again, to get as much sunlight as
analyzed.
possible, and they'd scout out the spot with an unmanned sample return mission in the early 2020s. The area also has lots of water ice, which would provide drinking water and could even be converted into hydrogen, which could be used for fuel. Construction would start sometime in the 2020s when a capsule would land with an inflatable habitat that could support a crew of 4. Then, remote-controlled robots would use the gravelly rock on the moon's surface, known as the lunar regolith, to form a shield around the habitat, protecting it and the people inside from radiation and damage from things like lunar dust. So between NASA's plans to send humans to Mars and all this talk of setting up a base on the moon, the world's space agencies have some ambitious
colonists
goals, which means
have
the next couple of
arrived.
decades of space exploration will be really exciting. Thank you for watching this episode of SciShow Space News.
Mars
and
has
thanks especially to our
ways of
patrons
crushing
on
the hope
Patreon
out
who
of our
help make
very
this show
best.
possible. If you want to help us keep making videos like this, just go to patreon.com/scishow. And don't forget to go to youtube.com/scishowspace and subscribe.
What if you woke up tomorrow and that giant rock 400,000 kilometers away was just gone?
Hey everyone, thanks for tuning in to D News Plus for episode 2 of 3 on leaving Earth. Because it's gonna happen. So far, we've talked about how we find habitable planets and why we have to leave. So if you don't know why we have to leave, go back, figure that out, and watch the episode. We're also going to talk about what plans we have for leaving Earth and if we could terraform a planet to fit our needs at all. Can we do that? And also, what would a society on another planet even look like? It's going to be really, really cool. Make sure you subscribe so you get all the episodes. Let's kick into it. So let's say we find somewhere we want to go. You know, we've chosen to leave, we've got some people who want to go there, but the conditions on that planet aren't exactly what we need to survive. Can we tweak them? People who are familiar with a lot of real-time strategy and science fiction probably have heard the term terraforming, the idea that you can change a planet to make it better for you. It's been featured all throughout science fiction. It's kind of hard to find that perfect place, so terraforming does come into play even just slightly, right? Making an imperfect place perfect. Let me tell you a quick story. Kid Trace, little Kid Trace, like maybe 10 years old, thought global warming, it's damaging our planet, it's making it deadly since the 1800s, nice job humans, why not put carbon spewing factories on Mars, thicken up their atmosphere, it'll nice, you know, a little warm up, like a little warm blanket on Mars. Not a bad idea, little Trace. Scientists have thought about it. We can't just pop over there though, it's kind of far. There's also no atmosphere or a planetary dynamo to hold the atmosphere in place. There's not enough gravity, there's a number of other things, but whatever. Nice job, little 10-year-old Trace. But scientists are thinking about this stuff really seriously. So let's talk about Mars first. Mars, it's probably our best bet for a lifeboat planet. It's pretty void and desolate though. Basically, we would need to cut the UV, raise the temperature and pressure of the atmosphere, introduce water, and fix that atmosphere to make it Earth-like. It's a lot of stuff. Mars's atmosphere is 95% carbon dioxide, almost 3% nitrogen, a little less in argon, very little oxygen, 0.13%, and a little bit carbon monoxide. Its atmosphere is 100 times thinner than Earth's. It even has trace elements of other stuff, but that's not as important. That thin atmosphere and being further from the sun makes Mars way cold. Atmospheres are like planetary blankets. I was joking earlier, but not really, because it keeps the heat in. It's what our planet does all the time. The average temperature is about minus 80 degrees Fahrenheit or about minus 60 Celsius on Mars. And it can change pretty drastically. In a Martian summer, it's not too bad. It's 27 Celsius, nice balmy day. But in the winter, it can get really, really, really cold. The atmosphere is still thick enough to support weather and clouds and wind and stuff, but not much. Because it's so thin, if you were to somehow walk onto Mars without a spacesuit, the low pressure would make your blood boil. It would be bad. Not like in a hot way, but it would become a gas. Not good. There are hopes of making Mars more Earth-like by terraforming, essentially changing the climate for human colonization. It first was actually proposed in science fiction. Arthur C. Clarke, my boy, love that guy. Sands of Mars. Martian settlers heated Mars by converting Mars's moon Phobos into a second sun and growing plants there to break down Martian sands and release oxygen. This is obviously not realistic science fiction. Beyond fiction, increase on Mars by about 3 degrees Celsius. Melt 1 trillion gallons of water already present on the planet, thicken the atmosphere, and it has an added bonus of introducing oxygen. Win, 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 win. Except, of course, grabbing an asteroid, strapping an engine to it, smashing it into another planet. It's a little harder. There are a bunch of different thoughts and ideas throughout the years of how to terraform a planet. Most have something to do with introducing a greenhouse gas, shout out 10-year-old Trace, or CFCs, chlorofluorocarbons, to trigger global warming effects. But more recently, experts were thinking of terraforming Mars by freeing heat-trapped carbon dioxide from the Martian crust back into the atmosphere. Essentially what we're doing with oil, but doing that there on Mars. And it actually seemed pretty feasible until you look at the results from NASA's MAVEN, Mars Atmosphere and Volatile Evolution mission from late 2015. I'm sure you've all looked at those results. I know I have now. And that showed that the CO2 levels on Mars went up and then not down after its atmosphere was stripped away. That's right, its atmosphere was stripped away by the sun. The solar wind pulled the atmosphere off the planet. It didn't have an electromagnetic field like we do, generated by the core of the Earth spinning, they think, to protect us. It also didn't have enough gravity to hold on to all of those molecules. According to the principal investigator of the NASA MAVEN mission, Bruce Jakosky, those molecules have been removed from the solar system entirely. It's not possible to bring it back, it being Mars's atmosphere. Oh, and by the way, any of these strategies, whether it's an asteroid with a giant engine or a greenhouse gassing up Mars or something, we'd have to figure all of this out, remember, from earlier. By 2050, when the population hits too much for Earth to stand, we're running out of time, guys. Most terraforming plans are not nearly as fast as Total Recall's few-minute planetary change. You gotta do more than that. Also, original Total Recall. Don't even start with me. Plus, the planet is still too small and has no electromagnetic field, so even if we did build an atmosphere on Mars, the sun would slowly throw it away like socks in a dryer and just disappear. So Mars, not as great when you get down to the brass tacks. But what about the moon? Can we live on that? It's closer, right? One of the first times the idea of living on the moon was more than just science fiction was actually pretty recently in the year 2000. NASA published a study and they found that a colony could be dug under the surface of the moon and still be okay. Or in an existing crater, you just cover it over. So inhabitants wouldn't be bombarded by that harmful cosmic radiation, and since the moon has no atmosphere at all, you would have to build something anyway. Luckily, dirt is actually a pretty good reducer of radiation as well. Nuclear fallout can be blocked by like a foot and a half of dirt or concrete, and packed at the right density. A 2008 study by NASA's Lunar Science Institute found that lunar regolith can also do that. It can also block radiation. So if they go underground they would have a lot of radioactive insulation from these cosmic solar particles. But recently, the idea of colonizing the moon has resurfaced, pun intended. There was this one idea from Professor of Astrology and Geology at Mount Holyoke College, Darby Dr. She says the moon is to people today what the New World was to Europeans 600 years ago. It wasn't a direct quote, but paraphrasing. Here is a direct quote, though. Quote, they had been there a few times, but it took time to work up the courage and send people there to stay. And that's just what people are planning to do. In early 2016, a group of space experts that included leading NASA scientists outlined a plan to colonize the moon by as early as 2022. That's really soon. That's like not the next Winter Games, but the one right after that. You know, like 6-7 years, that's crazy. And they could do this for only $10 billion. But the moon, that's not the end goal. The moon is just a starting point. It's used to get a base off of Earth to help us get to a point where we can go colonize other planets like Mars. According to Chris McKay, the same Chris McKay that we quoted earlier, quote, we are not going to have a research base on Mars until we can learn how to do it on the moon first. The moon provides a blueprint to Mars. The research papers included in the study outlined the plan. The lunar base would house around 10 people for a year at first, and they were hoping it could become self-sufficient and have maybe 100 people within 10
Sector
years.
scanned.
I mean,
Anomaly
that's amazing.
found.
People are literally planning to do this. We live in the future right now. I love this. Good old Elon Musk is going to help them get there too. SpaceX's Falcon Heavy rocket would transport them to the moon with a hefty payload of everything that they might need initially, all of the water and carbon and everything we were mentioning earlier. And then basically everything they would need after that would be 3D printed in terms of the tools that they would need. There's another series we've been wanting to do, 3D printing, so let us know if you think that that's still interesting and cool. They also have a nice spot already picked out for this colony in their paper, somewhere on the outer rim of one of the moon's poles, because the sun would be there. They could solar power a lot of stuff, and living near the poles would provide a ton of power, 24-hour sun, essentially. Power for robots to collect ice and humans that
Breakthrough
need ice
discovered.
because it has water to survive. Speaking of water, by the way, remember Darby Dr.? Of course you do. I said it just a few minutes ago. She is serving on the Solar System Exploration Research Virtual Institute, and she's working out how and where we can find water on the moon. She says that water on the moon can come from a few different places. Some, it's locked in the minerals in super tiny amounts. Basically, it's been there since the moon formed, and it's by super tiny, like we're talking real tiny. Some could have come from comets, but comets, you know, they're made of ice, so we can just capture some of those, hopefully. But another way that I found to get water on the moon that was super interesting is from the solar wind. And this is how she describes it. Quote, solar wind is composed of highly charged particles, some of which are hydrogen ions that bond with microscopic particles. They are spraying the moon all the time, and sometimes they stick. So if we can capture that hydrogen, mix it with a little oxygen, we got ourselves some water. And that is a crazy solution. So we've got people on the moon, we've got water, we know pretty much where they would live, but what would they live in, right? We have to build stuff. They would most likely live in something like a Bigelow Aerospace inflatable habitat. There's one called the B330. It's an expandable or inflatable habitat. NASA was testing one with the TransHab, and it can house up to 6 people. Has a 20-year lifespan, 330 meters of usable volume, which is pretty good. It also has 18-inch thick walls, so you don't have to worry about radiation. That's actually more than the ISS. But again, this is all the plan for the moon or Mars, which we can't do. So what about other than our neighbors? What do we do? Well, again, every planet is different. Every star is different. Every orbit is different. Every planet is going to have different considerations. What we do know is we know how to build certain things that can be used to make planets more habitable. This is why most of our constructions are little bubbles and things, you know, in science fiction. But what if we think bigger, right? What if we encased a whole planet in something that we know would terraform that planet? By encasing a whole planet in a shell made of Kevlar, dirt, and steel, as proposed by engineer Ken Roy in late 2013, we would be able to have radiation protection, heating and cooling would be controlled, the length of the day wouldn't be dependent on the orbit of the planet around its star. It's also crazy. It's a crazy plan, but then that's kind of far off. Another terraforming plan was to build 200,000-pound mirrors in space to reflect sunlight onto planets like Mars, because that could heat it up and be more comfy. I don't think this is worth it, you guys. This sounds really complicated. But we still have to leave Earth. We still have to go. So
Research
why don't we
complete.
just skip over the terraforming part? Because it looks like it would take hundreds of years to terraform a planet, both in coming up with the technology and figuring out how to do it. And even if we crashed an asteroid into Mars, it's not like Mars is gonna clear out in 5 minutes and be ready to go. You know, it's gonna take a long time to terraform any planet, and we only have till 2050 when we run out of food, so we gotta start figuring this out. Plus asteroids, they could show up at any time.
Sector scan.
So let's just assume we have a
Select sector
habitable
to
planet
scan.
somewhere, and assume that we can get there. Then what? If we leave Earth, what does this new place look like? Who gets to go? What are they gonna do when they get there? Are they one nation? Are they a new society? Do we have country allegiances? Are there like Japanese people and Americans and Russians and South Africans, you know, and Brazilians, or are they just all Terra Novans or something? And then looking way down the line, how is that planet going to affect and transform humanity as a whole? Are we going to evolve by going there? I mean, this is crazy. Why don't you let us know your thoughts on these questions down in the comments, because some of these are open questions and some of these we have ideas about. So make sure that you come back for tomorrow's episode to find out what those are and participate in the conversation down in the comments, because that's like half the fun of doing these videos. Again, thanks so much for tuning in to D News Plus, everybody. We'll see you tomorrow.
This episode of Real Engineering is brought to you by Skillshare, home to over 20,000 classes that could teach you a new life skill. Ever since man landed on the moon, we've been dreaming of colonizing it. We have the technology to get there. The only thing that is standing in our way is the cost of sending materials to the moon. While companies like SpaceX and Blue Origin are aiming to reduce the cost of rocket launches, the real challenge will be using the materials available to us on the moon. Luckily for us, the moon has no shortage of raw materials for us to exploit, but new technologies will need to be developed in order to extract them efficiently. This would give the lunar colony the materials necessary to build and expand, but more importantly, stimulate a lunar economy where it can sell the materials it gathers, like rocket fuel and rare metals. So what materials are available in the lunar soil? The elements available differ with regions on the moon. Water will be a high priority resource, and in 2009, India's Chandrayaan-1 lunar satellite detected ice at the moon's poles. The poles are likely the best candidate for our first moon colonists, but not just for the water. There are regions on the poles that receive almost continuous sunlight, like the ridges of the Shackleton crater, allowing these early colonists to bring solar panels with them and have a continuous supply of energy. And energy will be in high demand as all extraction techniques will need to be electrified. The most efficient method of extraction of the lunar ice will be to simply collect the lunar soil containing the ice and place it in a microwave oven, where it will evaporate at very low temperatures thanks to the vacuum on the moon. The vapor will then be condensed and collected. Our next commodity that will be in high demand is oxygen, and surprisingly, oxygen is one of the most abundant elements on the moon, but it is trapped in the form of oxides, like iron oxide, aluminium oxide, titanium oxide, and silicon oxide. These are valuable materials, and if we can create oxygen as a byproduct of their extraction, that just makes it all the more worthwhile. Iron will be a vital material for any lunar colony. Here on Earth, it is so vital for modern society that its production and utilization is a clear indicator of economic growth. It reinforces our buildings through rebar, it holds the weight of our electrical grid on its shoulders, and it bridges our oceans and rivers. And it is heavy, making it far too expensive to transport to the moon. To produce iron with current methods, we first need to mine limestone, coal, and the iron ore itself. The coal is refined into coke by baking off impurities like tar and water in a coke oven, which itself is an energy-intensive process. This coke is then used as a fuel source in a blast furnace to reduce our iron ore by producing carbon monoxide, which reacts with the iron oxide ore to form iron and carbon dioxide, while the limestone breaks down to carbon dioxide and calcium oxide, which reacts with the impurities in the ore. The pig iron produced then needs further refinement in an oxygen furnace to produce steel. This process will need to be streamlined for any lunar colony, as shipping heavy fossil fuels to the moon purely to extract iron from its ore is simply not an option. To add some incentive to develop this technology, this complete process contributes 1.7 gigatons of carbon dioxide to the atmosphere annually, 5% of total global emissions. Developing a fully electrified version will allow us to manufacture emissions-free steel. NASA offered a $250,000 prize to the first research team that could develop a reasonable method to process these resources on the moon while producing oxygen as a byproduct. Donald Sodaway, a professor of materials chemistry at MIT, proposed using an electrolytic cell. This cell would use an electric current to separate the metals and release the oxygen from its bonds. Aluminium production already uses electrolysis to refine aluminium oxide. Aluminium oxide has a very high melting point of 2072 degrees Celsius, and so to reduce the energy required, the aluminium oxide is instead dissolved in molten cryolite, which has a lower melting point of 1012 degrees Celsius, and thus this method reduces energy requirements substantially. This molten mixture is then placed in a steel case, which is lined with a graphite cathode. The anodes are also made from graphite. When an electric current flows, aluminium ions form at the cathode, where they gain electrons and sink to the bottom to form molten aluminium that can be topped off. Meanwhile, the oxygen ions accumulate at the graphite anodes, where they react with the carbon in the graphite to form carbon dioxide. This will be the general process for metal extraction on the moon, but graphite is obviously off the table as a material for our anode and cathode if we want to produce oxygen, as it produces carbon dioxide and is consumed in the process. Carbon is in short supply on the moon though, so this may be a clever way of producing carbon dioxide on the moon for plant growth. In a paper published in 2012, Sadoway and his research partner, Antoine Eleanor, conclude a chromium alloy anode is the best choice, as a protective and conductive layer of chromium and aluminium oxides form on its surface. This allows it to trade electrons with the negatively charged oxygen ions without being heavily corroded in the process, and oxygen is formed instead of carbon dioxide. This will be an incredibly energy-intensive process, and it's one of the main stumbling blocks currently stopping it from being used here on Earth for iron refinement. It's one of the main reasons aluminium is more expensive than iron. Generating electricity on the moon will initially rely on lightweight solar panels shipped to the moon, but for a moon economy to grow, it will need to be capable of expanding its own electrical grid. Aluminium is readily available on the moon, and it can be used for wiring like it is here on Earth for high-voltage power lines. The primary material used in solar panels is silicon, which is abundant on the moon, and applications go far beyond just solar panels. It can be used to make glass, and it's used to alloy with aluminium and iron. While solar panels' primary material is silicon, the silicon we find in solar panels needs to be incredibly pure, and its production also requires a carbon supply in the form of coke or charcoal. I couldn't find any technologies being developed to free its production from these feedstocks, which are not available on the moon, and ultimately I think sending lightweight solar panels from the Earth to the moon will probably be more economic until new technologies are developed. The moon has a rich supply of helium-3, however, thanks to solar winds, and if we manage to develop nuclear fusion technologies, generating power on the moon will become vastly easier and allow the moon to develop a healthy economy, harvesting this gas and sending it back to Earth. Ultimately, a self-sustaining moon colony will depend completely on its ability to harvest and make use of the materials available to it. And thankfully, the technologies being developed for that purpose have uses here right on Earth for freeing us from dependency on fossil fuels. As always, striving to do what is difficult challenges humans to develop and grow as a species. This is why the space program is important. Challenging ourselves is a core part of being human. It allows us to discover things about ourselves and learn what we are really capable of. And so, it's important for you to continually challenge yourself by learning new skills. These days, you can teach yourself pretty much any skill online, and Skillshare is a fantastic place to do it. With professional and understandable classes that follow a clear learning curve, you can dive in and start learning how to do the work you love. From creative skills like animation and illustration that allowed me to grow this YouTube channel, to business courses like this one that may help you turn that idea of yours into a high-growth business. A premium membership begins around $10 a month for unlimited access to all courses, but the first 1,000 people to sign up with this link will get their first 2 months for free. So ask yourself right now, what skill have you been putting off learning? What project have you been dreaming of completing but you aren't sure if you have the skills to do it? Why not start right now and sign up to Skillshare using the link below to get your first 2 months for free. You have nothing to lose and a valuable life skill to gain. As always, thanks for watching, and thank you to all my Patreon supporters. If you'd like to see more from me, the links to my Instagram, Twitter, subreddit and Discord server are below.
No active research. Research complete. Anomaly analyzed.
First time it was about two superpowers trying to prove their technological prowess, and they set the moon as their objective. And then we realized there's a lot in space that we can actually utilize. The oxygen that you need, the propellant, the rigs to build a home are already there. You don't have to bring it from Earth. That's the value of resources. The living of the land concept is the one that we're searching for right now. That is going to enable more exploration, allow us to travel further. It has been realized not just by our own space agency, but by dozens of space agencies around the world, by companies that they see an opportunity here to get involved. And when you get the whole world behind something like this, you know that it's time to go.
The moon is shaping up to be a critical destination in the 2020s. The big vision, establish it as a celestial boom town, where new technologies can be tested and the moon's raw materials can be harnessed to power future missions.
Space resources is anything that you can use beyond Earth. It could be solar power, microgravity. We're going into a totally different phase of space. First time it was about two superpowers trying to prove their technological prowess, and they set the moon as their objective. And then we realized there's a lot in space that we can actually utilize. The oxygen that you need, the propellant, the rigs to build a home are already there. You don't have to bring it from Earth. That's the value of resources. The living of the land concept is the one that we're searching for right now. That is going to enable more exploration, allow us to travel further. It has been realized not just by our own space agencies, by dozens of space agencies around the world, by companies that they see an opportunity here to get involved. And when you get the whole world behind something like this, you know that it's time to go.
The moon is shaping up to be a critical destination in the 2020s. The big vision, establish it as a celestial boom town, where new technologies can be tested and the moon's raw materials can be harnessed to power future missions.
Space resources is anything that you can use beyond Earth. It could be solar power, microgravity, it could be vacuum in space, or it could be something more concrete, like metals and minerals and
Welcome to Think Seeds. Please like and subscribe if you enjoy this video. Can you imagine a time when resources are no longer scarce and humanity has settlements in the deep reaches of our solar system? Key elements needed for modern industry and food production will be exhausted within the next 40 years. Asteroid mining, along with mining operations on the moon, will be an important key to unlocking interplanetary travel and near infinite resources. Though there will be a few hurdles to take along the way. The first is the legality in claiming and selling of these resources. The Outer Space Treaty of 1967 states in Article 2, outer space,
No
including the
active
moon
research.
and other celestial bodies, is not subject to national appropriation by claim of sovereignty by means of use or occupation, or by any other means. This basically states countries cannot convert space resources into private property and sell it. But what about private citizens and companies? The treaty goes on to say in Article 4, states shall bear international responsibility for national activities in outer space, whether such activities are carried on by governmental agencies or by non-governmental entities. Okay, so private citizens and companies cannot claim and sell these resources, right? Well, not quite. And mind you, we're talking about establishing precedent over a foreseeable market of hundreds of trillions of dollars and more, and reshaping the known economy completely. The U.S. Commercial Space Launch Competitiveness Act of 2015 states, a United States citizen engaged in commercial recovery of an asteroid resource or a space resource shall be entitled to any asteroid resource or space resource obtained, including to possess, own, transport, use, and sell. Companies took this as the green light to privatize space resources, though there are still conflicting interpretations. One of the key precedents cited in support of the claiming and selling of space resources was when Russia sold moon dust to a private citizen. Great. Now we can get busy and start mining. Actually, not yet. Suitable asteroids need to be identified and have their compositions analyzed along with their mining feasibility against financial models. Our solar system has over 150 million asteroids. Over 9,000 have been identified as near-Earth orbit asteroids, and 12 of these could have their velocity manipulated into an Earth-accessible orbit with current technology.
Resources are low.
There are
Sector
three
scanned.
main types
Anomaly
of asteroids:
found.
C, S, and M types. C-type asteroids carry an abundance of water that can be used as fuel by splitting the hydrogen and oxygen through electrolysis. The concentration of phosphorus in these asteroids will be critical for fertilizers and the growing of food. S-type asteroids have less water, but contain many metals such as iron, nickel, silicate, cobalt, gold, platinum, and rare earth metals used in electronics and hyper-technologies. M-type asteroids are the rarest and contain 10 times
Anomaly
the amount
analyzed.
of metal as S-types. In the last decade, 2 companies were at the forefront of asteroid mining: Planetary Resources and Deep Space Industries. Planetary Resources was the darling of this new industry and raised $50 million in 2012 from the likes of James Cameron, Google's Eric Schmidt, and the Luxembourg government. They made hyperspectral sensors to analyze the composition of asteroids and also worked on the development of an optical laser communication system needed for data transmission and remote control of autonomous mining robots. Deep Space Industries spent 3.5 years investigating the feasibility of space resource utilization and would pivot its resources into the development of propulsion
Electrostatic
systems
dust
and
storm
spacecraft
approaching.
capable of traveling into deep space. Planetary Resources would be bought out by Consensus, the Ethereum blockchain group co-founded by Joseph Lubin in 2018, and Deep Space Industries would be taken over by Bradford Space in 2019.
Research
So what
complete.
happened? The business models did not work the way they had hoped. Venture capitalists have an investment horizon typically up to 10 years. While the runway needed for these companies to enact their plans would be decades. The money wasn't there. The consideration for infrastructure requirements was oversighted. Asteroid mining would very likely require a moon base to process the material along with an orbital propellant and transport station. Not only that, but the creation of space probes, transport ships, deep space communication relay systems, and automated mining robots would all be needed. VCs are still investing into space. though they have an appetite for shorter timelines. 80% of new space industry capital is being deployed into the much more accessible satellite business. Last year was the largest year for space investment, with $5.8 billion invested. It is important for these companies to become profitable first before chasing long-tail endeavors of space mining. A hope is that NASA and other space agencies will build out the infrastructure for their exploration missions and leave it behind for the private sector. Okay, so asteroid mining is going nowhere. No, just wait. Japan's space agency, JAXA, with its Hayabusa 2 spacecraft, successfully landed on an asteroid, took samples, and will return to Earth. Granted, the sample size was very small. Honeybee Robotics is developing autonomous drilling systems that will extract resources from asteroids. TranAstra is researching optical mining and heating techniques to melt asteroid ice and capture its resources. Companies like
Anomaly
SpaceX,
analyzed.
Blue Origin, Lockheed Martin, Boeing, Honeybee Robotics, Made in Space, and TranAstra are just a few companies developing the groundwork for the infrastructure needed for space mining down the line. SpaceX's and Blue Origin's reusable rockets will be vital in transporting payloads into space cost-effectively in order to build out orbital stations, propellant depots, and a moon base. It is very likely if any asteroid mining is to be done, the resources will need to be processed on the moon. NASA's Artemis program has the goal of establishing a sustainable human presence on the moon and making an orbital lunar gateway used as a transfer point and communication relay. There are currently 14 companies in NASA's Commercial Lunar Payload Services program. SpaceX has proposed their Starship vehicle, while Blue Origin has proposed their Blue Moon lander to make payload deliveries to the moon. This is key in establishing a moon base and serious asteroid mining down the line. The water ice on the moon's south pole will be fully utilized, and the helium-3 in the moon's topsoil could be used to fuel nuclear reactors. Payloads to the moon start in 2021. It appears first we must master resource extraction and utilization on the moon before we move it onto asteroids in any meaningful way. Human consumption is growing exponentially, even with our efficiencies. We would need 5 Earths if we were to maintain the current rate. Key resources that make the modern world will be gone in the next couple decades. Nutrients are being depleted from soils, habitats are disappearing. Global warming from our large carbon footprints will change Earth for the worse. There are different solutions to this problem. 1, people consume less.
Resources
the
are
cyclical nature
low.
of consumption and resource extraction into profit needs to be sustainable. Or solution 2, we extend our political economy of capitalism and our heavy industry into space and mine near infinite resources from asteroids. But will it be too late by then? Collaboration between countries, companies, NGOs, and individuals is critical to enabling the future we want to have. Thank you so much for watching. If you enjoyed this video, please like and subscribe. I hope to make more docs and essays about people, companies, art, and society. Until I see you on the next one, have a great day.
Asteroid mining could shift from science fiction to world-changing reality a lot quicker than you would think. In this first episode, we are going to introduce the idea of space mining and what it would actually entail. Future episodes will cover a range of topics, including potential technologies, the financial equation of space mining, and even some of the legal problems that we could face when carrying out this bold new endeavor. So first things first, what is an asteroid? Asteroids are leftover material from the early formation of the solar system, some 4.5 billion years ago. Many are unaltered collections of raw solar system material, with a handful being debris from the destruction of partially formed planets that collided in our solar system's infancy. The position of these asteroids vary wildly, with some passing close to the Sun, while others are found way beyond the orbit of Neptune. However, the vast majority have been captured by Jupiter's gravity, forming a belt between it and Mars, an area known as the main belt. This belt holds more than 200
Research
asteroids
complete.
with diameters larger than 100 kilometers, an estimated 750,000 larger than 1 kilometer, and millions of even smaller ones. Outside of low Earth orbit, many nearby asteroids are the most accessible destination in the universe, with many containing enormous quantities of accessible resources. We've learned a great deal about asteroids over the past few decades. From the 50,000 meteorite samples that have been analyzed, the modern investments in telescopic study, and from successful government space missions to 433 Eros, 25143 Itokawa, and a handful of other asteroids. One of the most important aspects to space mining is, why do it? The main reason to start harvesting asteroids is that they contain all the materials we need to live, as well as to pioneer an entirely new type of space business. During the early stages of the mining operations, it will start serving the demands of current space businesses, such as communications and remote sensing satellites, improving the services they offer. Currently, the space industry is held back by the high cost of launching equipment and supplies into orbit. This launch cost greatly limits the range of business activities that are viable. Once asteroid mining is able to provide the raw materials to be used in space, a supply chain can be established, encouraging new applications and new business models as entrepreneurs attempt to introduce even more services that people on Earth find useful. The possibilities are truly endless with asteroid mining, due to the wealth of new resources and opportunity to build economies beyond what we have on Earth today, and to allow humans to become an interplanetary species. Thanks for watching our very first animation, and we hope you enjoyed it. We are planning on creating more of these types of videos. However, with a crew of just 2 people, this does take a bit of time. So to hopefully have a quicker turnaround, we are creating a Patreon to hopefully fund this
Sector
and our other
scanned.
video projects. Even just watching and subscribing to our channel encourages us to make more videos. Thanks for your time, and I hope to see you on our other videos.
Resources are low.
Iron, gold, copper. Minerals are the lifeblood of the world's economy. From the Arctic Circle to the Sahara Desert, the $1.7 trillion mining industry supplies raw materials needed for everything, from skyscrapers to smartphones. But mining also comes with an increasingly critical environmental cost, one that may require us to think about off-planet solutions before it's too late.
Booster ignition.
Asteroids, moons, and planets in our own solar system hold an essentially unlimited supply of untapped resources.
The first trillionaires will be those who mine asteroids.
Resources like gold, platinum, and rare earth metals make some of those asteroids incredibly high-priced, but the most valuable element may be our most basic one.
What you want to mine in space is what you need a lot of.
And while humans have been mining for thousands of years, mining in space requires new, innovative technologies to realize any potential business and economic opportunities. Such technologies might just allow humanity to expand operations off Earth and take that next giant leap. These tiny dots represent the millions of asteroids in our solar system. Over the past 2 decades, government and private aerospace companies have been investigating their composition, location, and even possible payoffs to mine them. This one, known as Bennu, has an estimated value of $669 million. Ryugu, $82 billion. Better yet, an asteroid called Davida, which is valued at more than $100 trillion. And the reason for these high price tags? They're made up of valuable metals like platinum, gold, and iron.
We believe that asteroids have
platinum group metals, rare earth metals in higher percentages than you might find on the moon, for instance.
Only once in human history has an asteroid sample been brought back to Earth, on the Japan Aerospace Exploration Agency's Hayabusa mission in 2010. And even then, the return sample was merely dust particles. And the total cost of that mission? Approximately $250 million.
One problem is that compared to the moon, there's very little gravity. So somehow you have to attach yourself to the asteroid, whereas on the moon, the gravity will hold your processing equipment in place. So the general answer to the question, can we bring materials mined in space back to Earth? The general answer is no.
Bringing things from space to Earth only makes sense if what is retrieved is so extraordinarily valuable and just not available on Earth.
And even returning the most valuable asteroids could drastically devalue those materials. Take asteroid 16 Psyche, for instance. NASA is constructing a probe to launch in 2022 to study the potato-shaped object, which is roughly 95% metals, nickel iron, platinum, and even gold. Some estimates value the asteroid at $700 quintillion. NASA says it may be the inner core of a developing planet that somehow lost its outer layers, offering incredible insight into how planets are formed. If someone did manage to bring large amounts of this asteroid back to Earth, supply of the resources would skyrocket, meaning we'd have more of the material than we would have use for, causing the price to crash to almost zero.
Once we erode the rarity of a high-value metal or mineral, the value of that terrestrially could drop significantly.
Experts agree that a more likely scenario is materials mined in space will stay in space, jump-starting a whole new money-making industry.
Any spacefaring nation will have looked at what's called in situ resource utilization, which is a very common space term, meaning you use the resources where you are. So taking that model of if you need it in space, mine it in space, what would you be mining? Mostly you need fuel.
There's something else much more valuable for use in space that's abundant on Earth. Water. Not only can water sustain human and plant life for future manned space missions, the components of water, hydrogen and oxygen, can also be separated and reassembled to make fuel.
No
This
active
zero-emission fuel,
research.
called
Research
hydrogen fuel,
complete.
is the same used in spacecraft propulsion and fuel cell vehicles. Hydrogen fuel research in this new space race could also spur new technologies that can help fight climate change by speeding the elimination of fossil fuel use on Earth. And there's already a high demand for it, and an immediate business opportunity for risk-tolerant companies wishing to make a fortune. In a 2018 paper by industry, government, and academic experts, they estimated that for an initial $4 billion investment in a moon water mining operation, which is about the cost of a luxury hotel in Las Vegas, about $2.4 billion in revenue could be generated annually.
The sort of business case 101 for mining in space is, if you're going to launch something from Earth, it's going to cost you about $10,000 or $20,000 per kilo to get it into space. So if you need water for something in space, and you can produce it for less than $10,000 a kilo, then do it in space. The United Launch Alliance, ULA, they have put a price on water in space. They have said, we'll give you this amount of money for the water, which means people who are going out and trying to produce that water now have a customer.
In 2016, the ULA announced it's willing to pay around $3,000 per kilogram for propellant in an orbit less than 2,000 kilometers in altitude, called low Earth orbit, compared with the estimated price of $4,000 per kilogram to deliver the propellant from Earth. Most experts believe the Moon is a logical starting point for this. It has more gravity than an asteroid, making it easier to land, and its poles are thought to hold vast amounts of water ice. That potential volume of water has made it the focus of NASA's Artemis program, which aims to land astronauts on the Moon's southern pole, and also make the space agency a critical first customer for any water harvested on the Moon.
China, India, Israel, the US, Europe, everyone is now sort of focusing on the moon.
And all of these
scanned.
government programs are looking to set up shop for a water mining future. A fueling station on the moon could ultimately make current space ventures much cheaper and make future space missions possible. Although entirely theoretical at this point, here's how it could play out. Water is mined on the moon and a fueling station is set up. This would provide the first customers, most likely government agencies, with water for human consumption and fuel for spacecraft. Water-derived fuel could also be harvested on an asteroid. Vehicles or propellant transports then carry the fuel from the surfaces to a stable storage point between the Earth and the Moon. Fueling stations can also be set up in low
Resources
Earth orbit,
are low.
making it accessible to satellites and other spacecraft. As of now, satellites that run out of fuel are decommissioned. Extra fuel would allow them to stay in their orbits, increasing their lifespan. Since using a rocket to get fuel out of Earth's atmosphere is expensive, refueling in low Earth orbit can greatly improve the size, type, and cost of missions in space. The commercial launch industry like SpaceX would also benefit from these fuel depots. The use of
Breakthrough
lunar-based
discovered.
propellant and commodities may also provide a stepping stone for interplanetary exploration. But while there has been a renewed interest in the Moon, it hasn't been easy. In just 2019, missions to the Moon's surface by both India and Israel resulted in landing failures. And the technology to mine and extract these potential water reserves on the Moon and beyond is still unproven. But some entrepreneurs are still optimistic.
The answer is yes. The technology exists. We can put something together, we can send something to the Moon that can mine water. So we are sort of like a trailblazers, trying to figure out what's going on the Moon, what's below the surface.
Meet Honeybee Robotics. They've designed drills used in NASA's past Mars missions and have sampling and mining systems going on future planned missions to the Moon, Saturn's moon Titan, Mars' moon Phobos, and Jupiter's moon Europa.
We've been focusing on developing high-end, fully autonomous drilling systems from literally iPhone size all the way to the size that cannot fit inside this vacuum chamber behind me.
And that's why NASA has long relied on their expertise. Unlike your everyday drill from the hardware store, their drills overcome the numerous limitations of space, which include extreme temperatures and low gravity.
That means you have to be very, very imaginative, very innovative to solve these problems. You're essentially trying to do what we do here on Earth, but with a fraction of the power, with a fraction of the mass, with a fraction of the volume, and drilling is unforgiving. If you get stuck, if something goes wrong, there is no second chance.
The difficulty in drilling would delay placement of the second probe until the next day.
One of their innovative ideas, called PlanetVac, uses compressed gas to shoot material into a sample container. Its ergonomic design allows it to be inside the foot of a lander, and was chosen to go with NASA-funded payloads to the Moon and Mars' moon Phobos. For mining and extracting water on the Moon, they created the Planetary Volatiles Extractor, or PVEX.
Sector scanned.
And it not only drills, it mines.
Anomaly
It's based off a drill
analyzed.
that removes a cylinder of material called a coring drill.
But it's not just any coring drill, it's a system with heaters on the inside. So you drill down to required depth, you heat up the material that's on the inside of the coring drill. And ice turns into vapor, and vapor moves up the coring drill into a cold finger. So you're capturing water vapor like, for example, in your freezer when you have condensation. PVEX is a mining system. It can actually get into the soil, it can actually extract water, it can actually capture this water in a separate container. We have all the pieces together, and we can go to the Moon or Mars and mine it.
When it's tested on the Moon, which may happen in the next couple of years, PVEX will be the first end-to-end mining system deployed in space, and they have even more futuristic ambitions to use the PVEX drill. Like this one, that not only extracts and stores water, but uses it to propel itself, like a flying kettle.
WINE, it stands for the world is not enough. It's a James Bond stuff, it's very futuristic. It's a new concept of space exploration.
The main idea is to send hundreds of low-cost wine spacecrafts all over the solar system to give a clear atlas of asteroids that have water resources. Honeybee Robotics is one of the many startups that NASA is depending on to develop new innovative ideas.
There is a strong private-public partnership with NASA right now to come up with landers that we can send twice a year that will put payloads to the moon, payloads like instruments, like rovers, and also humans. We're doing it right now. Very, very exciting times.
By giving out multiple contracts, NASA reduces the cost for themselves and the entire industry.
We want to have numerous providers that are competing against each other on cost and innovation, driving down the cost and increasing access to space and industrializing.
Startup TransAstra, with a new infusion of $2 million from NASA, has teamed up with other space startups and educational institutions to prove its process for harvesting and utilizing water from asteroids without even touching them.
Optical mining is our patent-pending process for using highly concentrated sunlight or light from another source to excavate the surface without having to use digging tools to dig into it. And this is very important in space, especially for asteroids.
To help develop and prove this technology, they've teamed up with the Colorado School of Mines. It's known as the Optical Mining Testbed. First, they put the simulated asteroid in a vacuum chamber to recreate the conditions of space. Then, they use liquid nitrogen to cool a surface inside the tank called a cryotrap. Then, they turn on a giant light bulb, which imitates sunlight that they then concentrate into a beam, resulting in very high temperatures. The beam of light hits the asteroid target, fractures the sample, and then water and other materials are released and frozen onto the cryotrap.
The volatile materials, which include water, methane, carbon dioxide, other valuable materials that are common and cheap here on the ground, but very valuable in space, trapped on our cryotrap.
Well, that's pretty nice.
The same way that we would trap those chemicals in space for a real asteroid mining mission.
Optical mining bypasses the daunting task of trying to land on an object with such low gravity that it could simply break apart when touched, and there's no drill to potentially get stuck. But for this to work, they're targeting smaller asteroids the size of a beach ball for their tech demonstrator model, with plans to accommodate rocks the size of a cubic tennis court and bigger in future models.
We think the right thing to do is to rendezvous with the asteroid, match rotation with it, put a thin film bag around it, cinch that bag down, and then de-spin the asteroid. And now you have the asteroid in a container, so you can work with it in a practical way.
TransAstra believes that harvesting water on asteroids will not only make space travel more affordable for private industry, but it will make NASA's proposed missions to take astronauts to the Moon, Mars, and even asteroids possible within a budget that the US Congress may be willing to provide.
And we can cut out hundreds of billions of dollars and actually make it possible for NASA to do all those exciting missions in a period of just 20 years or so.
Sector scanned.
By harnessing the asteroids. Now what's really cool about it is that by using public-private partnership and working with companies like TransAstra, the infrastructure for space resource harvesting and commercial transport in space can be developed. So by NASA doing it this way, and NASA becoming the first user of these resources and this infrastructure for its exploration missions, then that infrastructure is left behind for industry. And that can create massive industries in space. Like it even becomes cost effective to build a space hotel.
TransAstra and partner Momentus will be on a 2-year contract with NASA to build their asteroid mining and in-space transportation prototype called Mini-B to provide optical mining in space.
We live in a very exciting time where we're going to be able to take that to space, and the resources of space are literally unlimited.
And those unlimited resources are what some universities are betting on. At the Colorado School of Mines, where TransAstra does its optical mining research, they now offer a graduate degree in space resources.
Our space resources program is the first of its kind in the world. There is anticipated to be a growing number of jobs directly in space resources. But the skills and practices of space resources can be applied to lots of other things.
And a huge benefit to space mining research is that a lot of this technology can be beneficial here on Earth. Like their 3D printer that uses materials on the Moon or Mars to make structures, and is modelled after startup Icon's 3D printer that is used to make homes on Earth. Their penetrometer is a tool on the end of a robotic arm that's being developed to take measurements on the Moon, but has applications for mining companies. And even a rover in a lunar testbed that can drill and prospect for resources has its benefits.
There are places on Earth where mining companies and equipment manufacturers are looking at applying smart robotic systems in terrestrial mines. They could go into places that are not safe for humans. They could work in much more confined, toxic environments than a person could.
And one country is doing just that, and hopes to leverage their expertise in robotic systems for mining remote, inhospitable locations that are almost Mars-like.
Recently, the administrator of NASA, when the head of the Australian Space Agency visited, was saying that the US is looking to Australia to be doing
Resources are low.
of extracting resources in space. One of the reasons why we in Australia want to get into this area is because of the strength of our mining industry, the strength of our mining automation, and the strength of our mining research. We see it as a way that Australia can establish a niche space capability.
Australia's high wages have caused some of the largest mining operations in the world to seek cost savings by using automation. Rio Tinto, the world's second largest mining company, has fitted operations in Australia with fleets of autonomous trucks, drills, and even the first driverless freight train network. Adapting these technologies could prove useful to space programs, and the use of space technology in mines, such as robotics, would be useful on Earth. The Australian Centre for Space Engineering Research at the University of New South Wales in Sydney was founded in 2010 and has 15 PhD current or graduated students researching space resource ventures related to Australia's needs and expertise.
What we are trying to do at the moment is to reduce the risk perceived by a large company, a mining company for instance, when they approach this type of venture. I think one of the main reasons that terrestrial mining companies should be looking at this problem is that they will benefit their terrestrial operations by learning some of these lessons. So if they look at the way that you need to automate on the Moon, that will help their terrestrial operation. If you look at the way you would analyse risk for this type of mine, they must learn new lessons, which should hopefully flow back to their risk analysis for terrestrial mines.
Although mining companies have terrestrial mining expertise and monetary advantages, only time will tell who will be the first to provide a fueling station in space.
In terms of making it happen, I actually don't think it'll be a startup, I don't think it'll be a space agency, and I don't think it'll be a mining company, but I think it will be a big company, probably driven by a high net worth individual. A company like Blue Origin, SpaceX, a company like that. Not necessarily them, but something like that.
Proving that this kind of mining is feasible could trigger an influx of profit-minded companies migrating off the Earth. Just one industry that would stake a claim on the vast wealth of space. Not only is the universe a place for exploration, for private companies it's a new resource. The key which will unlock new possibilities in technology, manufacturing, living and working, both at home and beyond Earth. And all of this will be the result of our next giant leap.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2.
The space race isn't just global superpowers duking it out for bragging rights and technological supremacy anymore. Private companies, lots of them, are rushing to commercialize not just the final frontier, but the active getting there.
I'm a sports guy. This is like March Madness to me. It's one and done. I got one shot to get to the end, or else I'm either going to fail, run out of money, or be gobbled up by someone else.
And whoever figures out how to make launch safe, affordable, and convenient is going to take the next giant leap.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2.
The space race isn't just global superpowers duking it out for bragging rights and technological supremacy anymore. Private companies, lots of them, are rushing to commercialize not just the final frontier, but the act of getting there.
I'm a sports guy. This is like March Madness to me. It's one and done. I got one shot to get to the end, or else I'm either going to fail, run out of money, or be gobbled up by someone else.
And whoever figures out how to make launch safe, affordable, and convenient is going to take the next giant leap.
Sector scanned. Anomaly found.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Research complete. Cold wave approaching.
This is Quantum Sonics. I'm Joy Garemican, your choice for a radio host.
Resources are low.
The colonists are...
Sector scanned.
Welcome back. Did you know that Mars has its own counterpart to the man in the moon? Early photos of the surface showed a stone formation that looked just like a man's face. However, this turned out to be shadows cast from a giant rock, together with the human propensity to search for faces in non-human objects, a psychological phenomenon called pareidolia. Oh dear, it's definitely time for the next song.
There are Earth-sick colonists. Anomaly analyzed.
Low, so low, will you travel with me to a place where
Breakthrough
we can
discovered.
be? Where the moon and the stars are running free. Low, so low, will you travel with me to a place where life is free? Where the moon and the stars are running free. Low, so low, will you travel with me to a place where we can be? Where the moon and the stars
Colonists are departing.
are running free.
Sector scanned. Select a sector to scan.
Where the moon and the stars are running free.
Research complete. Resources are low.
This is Quantum Sonics, and I'm Joy Goremican, your Martian host on the non-existing air above the hot crimson soil.
Mama, I'll take you home when you got into some troubles lately, long away from you. Mama, gonna let me hold you straightly, got so cold while you're waiting. Sometimes you're gonna be erasing me, honey.
Sector
It's
scan.
a shade on your palette. It's okay to be funny. Sometimes you're gonna let me gaze on you, honey. Get a phase on your target. Sooner or later you want it.
There are Earthsick colonists.
Mama, you rest your bones. Let your fingertips go down easy. Sweet like honey, honey. Mama, gonna let it hold you straightly. Got so cold while you're waiting.
Electrostatic dust storm approaching.
Sometimes you're gonna be erasing me, honey. It's a shade on your palette. It's okay to be funny. Sometimes you're gonna let me gaze on you, honey. Get a phase on your target. Sooner or later you want it.
Resources are low. Sector scanned. Resources are low. research. Research complete. Resources are low. Sector scanned.
I'm Joy Goremican, and you're listening to Quantum Sonics, music radio on the bringer of war, better known as the planet Mars.
We gather here today to bid a final farewell to
Yeah, then you know what it feels like to
Sector scanned. Resources are low. Funding received.
I'm Joy Goremican of Quantum Sonics, and right now I'm stunned by the view from the studio window. If you look up through the thin Martian atmosphere, you can see our two moons, Phobos and Deimos. Did you know that their names are Greek and mean terror and fright? Well, I hope this next song doesn't scare you.
One minute at a time to go from here and just
Resources are
wait
low.
out. 1 minute at a time, you lock your head and a curl falls out. One slowly comes to rise a miracle. One holy town. Oh, time, you end up slowly going in through my eye. Oh, run.
scan. Anomaly found. Colonists are departing.
are listening to Quantum Sonics, the music station for the new red world.
Research complete. Sector scanned. Resources are low. Meteor incoming. Anomaly found. found. Sector scanned. Anomaly analyzed. Research complete. There are Earth-sick colonists. Electrostatic dust storm approaching. Anomaly found. New colonists have arrived. We have a food shortage.
Our colonists are...
Sector scanned.
You're listening to Quantum Sonic's Martian Songs with an Earthly Touch. I'm your host, Joy Goremican.
Oh, let the rockets hit some fine line with a new arrive. Oh,
Sector scan. Select a sector to scan.
the ground. Oh, let the toxic rock your guideline, let it go around. Oh, let the rockets free your mind.
A colonist has died.
The recent colonist deaths are a worrisome trend which kept...
In the morning, so happy to be. Oh, let the rockets
A colonist has
lead to
died.
some kind of new life.
Colonists are departing.
Oh, let the rockets guide you.
A colonist has died.
In the morning, so happy to be.
Guide. Research complete. Sector scanned.
I'm Joy, and you're listening to Quantum Sonics. Iko's Papandreou, I guess he's Greek, wrote us a letter. Yasu, Joy. I listen to your show while I'm working, and I really like it. Sometimes I think about what things will be like in the future. Will our development be similar to what we saw on Earth, or will it be different? What do you think? Oh, Ikos, that's a very interesting and highly philosophical question. Giving a satisfying answer is extremely complex. There are so many facets to consider. For example, there are scientific aspects, social aspects, even spiritual aspects. I think we can conclude that it's always possible to speculate and guess, but in the end, the future always holds unexpected surprises. While we wait for the future to arrive, let's listen to another song. Colonists are departing. New colonists have arrived.
Sector scanned. Crop failure reported. No active research. Sector scanned.